Lesson 8.2 is also familiar to us, so hopefully this will give us some breathing room in Chapter 8. We're going to be talking about the Pythagorean theorem, so hopefully you remember that from way back in pre-algebra when you learned it. And that is a squared plus b squared equals c squared. Now the main thing to remember on this is what is c, because we can mix them up. C is the one letter that really matters where it is. C is always opposite the right angle. So in example 1, if you want to find x, you're going to use your formula and you need to know what to plug into where. A and B are your legs, so it really doesn't matter which is which. So let's say 4 squared plus 7 squared equals x squared. There's our formula. So now let's simplify it. 16 plus 49 equals x squared. Let's add 16 and 49, and we get 65. Well, 65, if we square root it, if you put it in your calculator, you'll notice it's not a very nice decimal. So instead of writing down a rounded answer, we want it to be accurate. It doesn't say to round anything. So we're going to leave it in a radical. X is the square root of 65. And that's going to be our answer because that is exact. Let's try letter B. Where's C? Opposite the right angle. In this case, we know C. We need to find one of the legs. So let's write it out. X squared plus 8 squared equals 12 squared. Let's go ahead and simplify. X squared plus 64 equals 144. So how can I find x squared? I can't just square root it like I did in the last problem. I've got to do a little bit of algebra and subtract 64 from both sides. So go ahead and subtract that, and you will get x squared equals 80. So that's not a perfect square either, so that's also a not nice, ugly decimal. So instead of leaving it, though, square root of 80 like that, there is a perfect square trapped under there. We can simplify it a little more, because 16 times 5 is 80. So 16 is a perfect square. It's 4. So we're going to simplify this even a little bit further to 4 roots of 5. That's an even better answer. That answer makes your teacher smile. A new topic for you may be Pythagorean triples. These are 3 numbers, 3 sides of a triangle that are all whole numbers. This is not a whole number, that was a decimal. This is not a whole number, that was a decimal. But Pythagorean triples are 3 sides of a triangle that when you plug them in to the Pythagorean theorem, you don't get ugly decimals. Sides like 3, 4, 5. It could also be a multiple of that, like 6, 8, and 10. So any multiples of these are also triples. Another Pythagorean triple is 5, 12, 13. Another one is 8, 15, 17. And the last one you need to memorize is 7, 24, 25. Remember, I put a note up there. You should memorize these. Why? Because ultimately it makes your life easier, because if you recognize something is a Pythagorean triple, you don't have to do the Pythagorean theorem. Something like example 2. You're going to use the Pythagorean triple to find x. You're not even going to do the Pythagorean theorem. How cool is that? No math. Well, a tiny bit. Anyways, I'm going to look here and think to myself, okay, 24. Hey, that Pythagorean triple has 24 in it, but the hypotenuse is 26, and that's 25. So it can't be this Pythagorean triple. So I have to think maybe this is a multiple of one of these other three. So I noticed that both of these are divisible by 2. So I'm going to think to myself, 24 is really just 2 times 12. And 26 is really just 2 times 13. I see a 12 and I see a 13 right there. So this is the Pythagorean triple, 5, 12, 13. But this side over here, is it 5? Not really, because you have to use what we did. It's a multiple of 2, so it's really 2 times 5, which is 10. So x equals 10. And I want you to try to explain your reasoning. We're going to talk about it in class tomorrow. So you write down why it's 10. You should use the words somewhere in your sentence, Pythagorean triple, in those 3 numbers. That's your hint for the day. Okay, example 3. Let's draw this out. We've got a building here. The window is 16 feet tall. Here's the ground. And here's my ladder. Amazingly enough, it looks like a right triangle. 20-foot ladder. I want to know how many feet away this ladder is from the building. Well, I could, of course, do the Pythagorean triple, or Pythagorean theorem, or I could see, hey, this is a Pythagorean triple, because this side 20 is 5 times 4, and this side 16 is 4 times 4. So my Pythagorean triple is a 3, 4, 5. It's a 3, 4, 5 triangle. So x, but it's a multiple of 4, so it's 3 times 4, which is 12. Okay, turn the page to number 4. And before we get to it, we're going to talk about 2 inequality theorems. These theorems are in your book, but instead of a squared plus b squared equaling c squared, this is saying that if you have an acute triangle, your longest side, which is always c squared, if it's acute, is going to be less than a squared plus b squared. If you have an obtuse triangle, then your longest side is going to be larger than a squared plus b squared. Okay? What that means, let's apply it so you can get a better understanding. We want to determine if these sides, 9, 12, and 15, not only if they are a right triangle, but if they are an acute or an obtuse triangle. And you'll notice there are no angle measures. So we have no idea what the angles are. And actually, we really don't care because we don't need them, because we have some pretty cool theorems up here we can use. So C is always our largest side. Always C. So let's plug this in. 15 squared, we don't know if it's equal, greater than, or less than 9 squared plus 12 squared. Let's find out what it is. So first I need to know what 15 squared is. That's 225. And 81 plus 144. So I'm going to add those two together. And amazingly enough, 81 and 144 are what the same what the other side is. So these are equal. Because it's equal, it makes it a right triangle. Because that would be the Pythagorean theorem. Letter B, let's try this one. C squared, what number is it? 10, 11, or 13? 13, very good. We don't know if it's equal to, greater than, or less than. Okay, let's simplify that. So 169, and we're going to compare it to 221. Is it greater than, less than, or equal to? 169 is less than. So because it's less than, that follows under our theorem 8.6. It must be an acute triangle. Excellent. And again, hey, it's our handy dandy, not notebook, but our little concept summary. These are the 3 main points of lesson 2 of chapter 8. Make sure you know them for the mid-chapter quiz coming up.